Two gliders having the same mass and speed move toward each other on an air track and stick together. After the collision, the velocity of the gliders is... So we know that the two gliders are moving toward each other, that they have the same mass and speed, so the same mass and magnitude of velocity. But since the two are moving toward each other, we know that those velocities must be in opposite directions. So the velocity of the first glider may be to the right, and the velocity of the second glider could be considered to be to the left. But the velocity of that second glider, since the two velocities are of the same magnitude, will be equal to the negative velocity of the first glider. So we see that the two vectors will have the same length, but they'll just be opposite in direction, which we can indicate with this negative. And that'll be important in just a second here. So to solve this problem, we need to employ the law of conservation of momentum, which tells us that the momentum of a system before an event, usually a collision, will be equal to the momentum of that same system after the event. Now we also know that momentum is equal to mass times velocity, and so the momentum of this system before the collision will be equal to the mass of the first glider, which we're told is the same as the mass of the second glider. So I'm just going to label it with a symbol m for both the mass of the first glider and the second glider. So anyways, it'll be this mass times the velocity of the first glider, which we're calling v1, plus the mass of the second glider, again m, times the velocity of the second glider, which we determine to be the negative velocity of the first glider. Now, this is going to be equal to the momentum of the system after the collision. So on the left-hand side here, if we factor out the mass, we'll be left with m times the velocity of the first glider minus the velocity of the first glider. And this in brackets will be equal to 0. And if the bracket is equal to 0, then we'll have mass times 0, which is equal to 0. So we end up with the momentum after the collision of the entire system must be equal to 0. Now we also know that the momentum after this collision will be equal to the mass of the system, since the two gliders have stuck together. That will be 2m, so 2 times the mass of an individual glider, times their combined velocity. So they'll be moving as one unit, and they will have some velocity, which we'll call velocity with a subscript f for velocity after the collision. Now, in order for this equation to be true, 0 equals 2m times final velocity, one of two things must also be true. Either the mass must be 0, which we know is not the case, or the final velocity must be 0. And that is the correct assumption here. So that final velocity must be equal to 0 in order for the momentum after the collision to be equal to 0. So the velocity of the gliders that are stuck together after the collision must be equal to 0.